We'll start to learn chapter 11. Now let's see. Now let me open our book. Actually, yeah, chapter 11. In this chapter, we'll learn how to calculate perimeter and area. So to do that, first we need learn some concept. Last chapter we already learned line segment. Suppose we have this line segment AB. We use AB, add a bar above these two letters, capital letters, to represent a line segment. But when we write the length, the measure of this line segment, we don't need that bar. We just add AB equals 2. Suppose this 2 centimeter, okay? Then, another concept called middle point. Middle point, that means you have a point on this segment, separate this segment as two equal parts. So you can see this picture. Suppose we have line segment XY. The M is the middle point of XY. Then XM will equals YM. So then we use a little tick here. This one XM equals MY. Then if we have another segment XZ equals YW, then you can use double ticks to represent these two line segments have the same length. So then in the geometry, usually we call this line segment are congruent. We use this word congruent. Use this word congruent means they're exact same. So later we also learned like two triangles are congruent. That means these two triangles exactly same. The difference is only the location, the direction. Maybe it's different, but they're each size and the angle of each angle also will have corresponding angles will same. Then we'll learn the concept called perimeter. Perimeter means you have a closed shape. Closed, that means suppose you have a triangle, you have three vertices of this triangle, suppose A, B, C. If you start from any vertices of this triangle, walk around, then you can return to that starting point. This one called a closed shape. Then any closed shape, they will have a perimeter. That means you add all the length of each side of this closed shape. Then you get a number, this number called perimeter. Suppose you have a rectangle like this. Then this also a closed shape, right? This one A, B, C, D. If you start from A, right, you can go counterclockwise. You can go this way, right? Then you can return to the starting point, right? You can also go clockwise, go this way, then you can return to starting point. So this means their closed shape. For any closed shape, then you can get the sum of each side we called parameter. Now let's do some example. Let's see this problem 11.1. So Grace, can you read this problem?
Farmer Fred wants to fence the oddly shaped region shown in bold at right. If each of the squares shown has sides that are 10 feet long and the fence costs $7 per foot, then how much will Fred's fence cost?
Okay. So do you have any idea to do this problem? See, they tell you each side of the little square that's 10 feet long. So that means, say, this one that's 10 feet, this one another 10 feet, this another 10 feet, right? This one. See, the shape they ask you to calculate, that's this solid highlight dark shape is this. Then first, to calculate that cost, you need to calculate the parameter of this arted shape, right? So first, you need to count how many this little sides this closed shape has, because each this little 9 segment equals 10 feet. So first, you need to count how many this little square segment you have in this ugly shape. So can you count how many we have?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
Actually, you missed very close, but you missed 2. The correct answer should be 24. Now let me show you. Say, if we count from here to here, that's 2, right? Say 1, 2. Now here, 1, 2, 3, 4. Here you have 4, right? Then now let's count here. 1, 2. Then 1, 2, 3, 4. 5, 6, 7, 8. We have 8 here, right? Then here 1, 2, have 2. Then from here 1, 2, 3, 4, 5, 6. Here have 6. Then you add all these together, see what you get. 10, 2 plus 8, that's 10, right? So 10 plus another 10. Oh, you got a 22? Now let's see this 2.
Yeah, you forgot the ones that are on the side.
Right. So let's see. This one, 1, 2, 3, 4. This is 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yo, yes. This one is not 8, that's 10. Okay. So, Sean, thank you. This one's 10. So then totally, then you add this number together, you get that's 24, right? So then you have 24 10 feet. So total length, that's 24 times 10. So that's 240 feet. So say each feet cost $7. So then you times 7. So can you calculate how much cost?
$1,480.
That's $1,680. Yes, this one's correct. Okay. So now I want to ask you another question. Is anybody has a shortcut to calculate this parameter?
Yeah, there's
How to do this? Quickly.
so like think so. I'm actually so you can, for example, this line is the same length of this line.
Yeah.
This is the same length of this line. So basically, you can actually draw it like this, and then it would still be the same parameter. And then you can do the same with these two, and you can also do the same with this. So then, and then you just keep doing that, and then you get like a rectangular shape like this.
Yes. Yes. Sophie, perfect. Yes, that's exactly I want to ask you. Say, push this one to here. Push this one to here. Push this side to here. Push this one to here. Then push this one to here. Push this one to here. Then you did not change the parameter. But then the shape, what you get is exactly this rectangle. Then for this rectangle, the parameter is very easy to calculate because this length, that's 1, 2, 3, 4, 5, 6, 7, is seven little line segment. For the width, that's 1, 2, 3, 4, 5, right? So then the parameter of this rectangle, that's 5 plus 7, then times 2. So you got this one equals 24. So later when you see this kind of problem, ask you to calculate the parameter, if that shape is very weird, then you can just push it to the side to outside, make this a rectangular. Maybe it will be a square. Then that will be very easy to calculate the parameter, right? You actually you don't need to count that one by one. You just calculate the parameter of that rectangle or square. Then you get the same answer for the parameter of this ugly shaped region. Okay. Now let's go to next example. Say this one, 11.2. Sean, can you help me read this problem?
Triangle is called equilateral if all of its sides have the same length. In the diagram at right, all three triangles are equilateral. Point D is the midpoint of segment AC and G is the midpoint of segment AE. If AB equals 4, then what is the perimeter of ABCDEFG?
Okay, I give you everybody 1 minute. Try it. Say here, they give you AB, length of AB, that's equals 4. Then here you have 3 triangles. They are all equilateral. Equilateral triangle, that means all their sides are same. Say ABC have the same length of side. Then D is middle point of AC, so that means this one equals this. Then G is also middle point of AE, so that means this one equals this. Then they ask you what is the parameter of this closed shape A, B, C, D, E, F, G, A. Everybody, if you have answer, you can send me the private chat. Now let me check. Sophie, you're very close. Double check. Still very close. See, let me draw something. Then we'll make this one more clearly. So from here, start from A, B, C, D, E, F, G, A. So that means we need to take away this part. And also we need to take away this part. Okay? See, now you count this shape, the perimeter of this shape. Yeah, Julia got it correct, Sean got it correct, Vienna got it correct. See, now, see this one will be 4, this one will be 2, this also 2, then this 1, 1, 1, right? So then you add 4 plus 2 plus 1, then plus 1, then this one times, let's see, 1, 1, 1. You have this one, actually you have this one times 2, then plus another one. So that's 7 times 2, 14, plus 1, you got a 15. Okay? See, you need to calculate like this. Take away this side and this side, because the parameter you only need to add the one lines. You should not add the lines inside of that shape. Only add the lines on the boundary of that shape, not the inside of that shape. Okay, so very good. The correct answer for this one is 15. Now let's go to next one. So Julia, can you read 11.3? Julia.
And C are on segment AD such that AC to CD equals 3 to 1 and B is the midpoint of segment AC. If BC equals 6, then what is AD?
Okay, so first, everybody, you need to draw a diagram on your scratch paper. Now, otherwise, you don't know what this one talking about, right? So first, you need to draw a diagram. Now, let's do this. See, first, they tell you point B and C are on segment AD. So now, let's draw AD first. Suppose this one's AD. This one's A. This one's D. Then point BC on this line segment, and AC over CD equals 3 over 1. AC, suppose C is here.
Playing from iPhone. Playing from iPhone.
Then AC over CD equals 3 over 1. And B is the middle point of AC. So B is middle point of, okay, B is middle point of AC. Then if BC equals 6, if this one equals 6, then they ask you how long is AD? Everybody do it. You know, what I draw here is not scaled. You cannot just see what I draw here, get your answer. You need to based on the problem give you. See, they ask you how long is AD. Okay, Sophie got it correct. Julia got it correct. Who else? Vienna got it correct. Yes, very good. See, BC is 6. Then B is middle point of AC, so that means AB also equals 6. So then AC equals AB plus BC, so that means AC equals 12. AC equals 12, AC over CD equals 3 over 1, so that means CD equals 4. So 12 plus 4, then you get the AD equals 16. Sean, you're very close. The correct answer is 16. Oh, Grace also got it correct. So for this geometry problem, first you need to draw the diagram. That's very, very important. Now let's go to 11.4. Let's see. Vienna, can you read this problem? Vienna.
A triangle is called isosceles if two of its sides are congruent. The two congruent sides are called the legs of the triangle, and the other side is called the base of the triangle. Suppose an isosceles triangle has a perimeter at 45 and the length of each leg is twice the length of the base. What is the length of the base?
So this problem, you also need to first draw a diagram. See, this is an isosceles triangle. Suppose we draw this one equals this one. Okay, then connect this. See, they tell you the two congruent sides are called legs of the triangle, and the other called the base. This one is base, right? Then the suppose isosceles triangle has the perimeter 45, and each leg is twice the base. Suppose base is B, then this one will be 2B, 2B. Then they ask you what is length of the base. Okay, Sophie got it correct. Who else? See, they give you the perimeter equals 45. Then they said leg is twice of the base. You know, this is an isosceles triangle. These two legs are equal. Julia, you're very close. Okay, now your answer is correct. Vienna got it correct too. Vienna correct. So this one, you suppose length of base is B. Then length of this leg will equals 2B. This one also equals 2B. Then you get the equation B plus 2B, then plus another 2B. This one equals 45. So that means 5 times B equals 45. So then B equals 45 divided by 5. I got a 9. So 9 is correct. Okay. Grace also got it correct. Very good. Now let's go to next problem. I go to this one. 11.5. Let's say Sophie, can you read 11.5?
Mary leaves home and walks 7 miles in one direction before stopping for lunch. Jeff leaves from the same home and walks 4 miles before stopping for lunch. Is it possible for Mary and Jeff to have lunch 12 miles apart?
Okay. Is this possible? Yes or no? Okay, Sophie is correct. Who else? Say this one, you can also draw, to solve, you can also draw a diagram first. So now, suppose this one is Mary. This start here is home, right? Then this one's Jeff. So the Mary walked 7 miles. The Jeff walked now. Okay, Jeff walked only 4 miles. So then, let me change this one a little bit. Draw this one again. So suppose this one is 4 miles. This is Jeff. Then they ask you the distance between Mary and Jeff. Can this one equals 12? Okay, Vienna also correct. Greece also correct. There's no way, right? Say even they go totally opposite direction, that will be 7 plus 4. That's 11, right? So how you can get their distance equals 12? So this problem actually tell you if in a triangle the sum of the other two sides is always bigger than the third size. You cannot have like 4 plus 7 is greater than 12. See, this distance between Mary and Jeff, will be the one side of triangle. You know, that number definitely cannot greater than the sum of other two angles, sum of other two sides. Right. So now let's go to B. See, this one said, is it possible for a triangle to have side length 4, 7, and 12? Why or why not? Definitely this one, the answer is also no. That's not possible. Because the sum of any two sides definitely will greater than the other sides. So then if you have two sides 4 and 7, how you get the other side equals 12? That's not possible. Then C. Suppose a triangle has side A, B, C. Is it possible for A plus B to be less than C? Is it possible for A plus B to equal C? No, it's not possible. Even equal is also not possible. Okay? Because this one is a triangle. You know, only when the equal will happen. Will like this. They go to the different direction, totally different direction. Right? Suppose Mary go west side and Jeff go to east side. Then this one's 7, this one's 4. So then you add these two distance together, that's equals 11. It's also less than 12. But then, see this way, 4 plus 7 will equals 11. But then they cannot form a triangle. You know, if this side plus this side equals MJ, that will be a line. That's not form a triangle. Okay, for a triangle, any two sides should greater than the third side. You cannot equals to the third side. If it equals to the third side, that's not a triangle. That's just a line segment. So we finished this section. Then your homework will be the exercise problem behind this section. Now let's go to second section. Second section, this one will try to calculate the area. The area that's actually you can think the area that's space contained inside of figure. Okay. Now, suppose you can use a 1 by 1, one square to usually you have a unit. Maybe that's a 1 square feet, maybe 1 square centimeter to cover that closed shape, inside of a closed shape. Then you need count how many this kind of squares can cover that inside of the shape. Then they will give you that number will give you the area of that shape. So now let's see example. Okay, suppose we have this rectangle. This rectangle we have the width that's equals 3, right? So you can see 1, 2, 3. Width that's 3. Length that's 1, 2, 3, 4, 5. Then you consider use 1 by 1 this little square to fill the inside of this rectangle. Then you need how many this kind of little square can fill out this rectangle. That's definitely 3 by 5. That's equals 3 times 5. That's equals 15. You need 15 this little square to fill out this rectangle. So that means area of this rectangle equals 15. So we use a square bracket to add to the name of this shape, this rectangle, WXYZ. You add a square bracket. That means you try to find the area of this rectangle. Then you got this one equals 15. Okay. Grace, you got the 18? I got 18. See this one 1, 2, 3, 4, 5. This one's 1, 2, 3. 3 times 5, that's 15. Okay, this is 15, okay, not 18. Now let's go to the example 11.6. See, in this problem, in a rectangle PQRS, PQ equals 4, QR equals 9. Then they ask you, what is the area of PQR? PQR. Oh, Grace, you did this problem. Don't go forward if I did not ask you to do that, okay? Then that would be really confused. I suppose you did that problem we are talking about. Okay, if your answer is for this, your answer is correct. Okay, so if we got it correct, Vienna got it correct. Okay, to calculate the area of triangle PQR in this shape, you can use 4 times 9, then divided by 2, because this one is a half area of this rectangle. That's equals 18. Yes. Julia also got it right. Sean got it right. Very good. So then also from here, you need to know for right, this one's a right triangle. That means that the angle equals 90 degree. Then the area of this triangle equals base times height, then divided by 2. So 4 times 9, then divided by 2, you got 18. Okay, so now let's go to next example, 11.7. See, this problem is the legs of a right triangle are the sides of the triangle that form a right angle. Suppose the legs of a right triangle have lengths A and B. Find a formula for the area of the triangle in terms of A and B. Okay, so if you got it correct, who else? Say if the length of these two legs of right triangle is A and B, then they ask you to give you a formula of the area of this right triangle. Vienna, they did not ask you to find the number. Actually, they did not give you the number. You should not write the number. They ask you to write a formula. You use A and B to represent the area of the right triangle. See, the problem is this. They give you, suppose this one is the right triangle. Okay, they tell you this leg suppose equals A, this one equals B, then they ask you to calculate the area of this right triangle. Okay, Julia got it correct. So the area of this triangle, suppose this one's A, B, C. This A, B, C of this triangle equals 1/2 of A times B. Okay, you can also write this one A times B over 2. This one's the correct answer. They did not give you the number. You should not write the number. The formula, that means you have the variables in that formula. Say A and B are variables. Then they can be any number, right? They give you A, suppose that's equals 1, B equals 2. Then you can get the area equals 1 times 2 divided by 2. That will be 1. Okay, so now let's go to next example. 11.8. See, this problem, Raven and Ranu are trying to decide how to paint a rectangular wall that is 18 feet long and 8 feet high. Ravi wants to paint a right triangle, as shown on the left below. Ranu wants to paint a more interesting triangle, like the one shown on the right. Then they ask you, what is the area of the region that Ravi wants to paint? So then they ask you, what is the area of this right triangle? Okay, now let's see. This rectangle, that's wall, is 18 feet long and 8 feet tall, right? Now let's see. They ask you to find the area of Ravi's triangle. Now let's see. Grace got it correct. Sophie got it correct. Julia got it correct. Okay. So this one, that's correct, 72, because the area of this right triangle equals 18 times 8 divided by 2, so equals 72. Okay, very good. Now let's see B. Divide the wall with Ranu's triangle into two rectangles such that the painted portion of each rectangle is a right triangle, what is the area of the region that Raul wants to paint? Okay, everybody do this. Number 2. Okay, you got the same answer, 72. Sophie got it correct. Vienna got it correct. Julia got it correct. Very good. See, this, the triangle of Raoul's triangle is also area, it's 72. Because the base 18, the height also 8. So 18 times 8 divided by 2, you got the same answer. Okay? Also equals 72. Very good. Now let's go to 11.9. Say, use your observations in the previous problem to describe how to find the area of any acute triangle. Okay. So how to find the area of any acute triangle? Okay. Base times height divided by 2. Yeah, Sophie, you're right. Very good. Base times height, then divided by 2. Now let's see 11.10. Ravi and Ranu are expanding their house so that the wall that was 18 feet by 8 feet before will become 20 feet by 8 feet. Ravi still wants a triangle that reaches from one color to the opposite color, but he doesn't want to use any more paint than he used for his triangle on the old wall. Ranu says they will just keep the bottom of the triangle as the same and extended the top to the new color as shown below. Okay, so then they ask you, is Ranu correct? Does Ravi need the same amount of paint for this triangle as he needed for his triangle in the problem 11.8? So actually they ask you, this triangle has the same area with the before. Okay. Vienna correct, Julia correct, Grace is correct, Sophie is correct. Yes, this triangle has the same area with before because the base is same, height is also same. Even the shape is very weird. It's totally different compared with the previous one, but their base is same, height is same. So then the area of these two triangles are same. Now let's go to 11. Say this problem, a median of a triangle is a segment that connect vertices of a triangle to the middle point of the opposite side. So that means AM. M is the middle point of BC. So if you connect AM, this AM called the median on BC, on 9 segment BC. This is called median. This one is connect from vertex A to the middle point of BC. You got this AM. Then, for example, in the diagram on the right, AM is a median of triangle ABC. Show that a median of triangle divides the triangle into two pieces with equal area. They ask you show that this median of the triangle separate the triangle into the two pieces with the same area. Okay, can everybody explain? why this one is true. Now let's see the two triangles we get. One is ABM, another is AMC. Because M is midpoint of BC, so that means BM is already equals MC. So then you can consider BM and MC is the base of these two triangles, right? So then the height of this triangle, you just need to draw from A to BC. Suppose they intersect with BC at a point that's D. Then this AD is not only the height of ABM, triangle ABM, it also is the height of triangle AMC. So then, say these two triangles, they have the same base, same height. Okay, now let's see, Sophie got it correct, Julia got it correct, Grace got it correct. Now let's see. Sean got it correct. Yes, very good. Everybody got this one right. Now that's the reason why these two triangles have the same area, because they have the same base, same height. Okay, now let's go to 12. Problem 12. See this one said Tina wants to carpent a room that has unusual shape shown on the right with solid lines. Each dotted square in the diagram has a side length 5 feet. What is the area of Tina's carpet? So this each small square, the side, that's 5 feet. See, this one's 5 feet, 5 feet, 5, 5, 5. Then they ask you what is the area of this shape. Everybody do it. Then send me the private chat of your answer. Now let me check. Grace, you're very, very close. Okay. Very, very close. Vienna, you're also very close. Now, Grace, you got a correct answer. Okay, how to do this? To do this, have two ways. Two ways to do this. Vienna, now you're still very close. Say, we can do this way. Yeah, now you're right. We can do this way. You can connect here, right? Then you can connect here. Then you can connect here. No. Wait. Actually, you can connect here. Maybe connect here. Take this away. Then we can connect from here to here. Then we also can connect here to here. Now let's calculate this small square, this small rectangle. This is 5. This one, 1, 2, 3, 4. So base is 5. This height, that's 20. So the area of this one is 50. This triangle, that's 50, right? 5 times 20, then divided by 2, 50. Then this rectangle, say 1, 2, 3, 4, 5, 6. 6 times 5, that's 30. 30, this one, 1, 2, 3, 4, 20. 30 times 20, you got a 600, right? Then this one, 1, 2, 3, 4, 4, that's 20. 20 times 5, 100. Now this one, base, that's 10. This height, 1, 2, 3, that's 15. 10 times 15, 150, then divide by 2, 50, 75. This one, 1, 2, 3, 1, 2. So that's 15 times 10, 150. Then this one, that's 10. This one, 1, 2, 3, 4. That's 20 times 10, then divided by 2. That's 100. Then you add this number together. Say 600 plus 50, then plus 100, then plus 75, plus 150, then plus 100. This one will give you answer equals 1075. This one is correct answer. Okay? So this is one way. Another way, you can do this way. You calculate outside. Later, you minus that area from this big rectangle. So you can do this way. You draw here to here. Then here to here, that's a rectangle, right? Then you can draw here to here. This is the rectangle. Now, this one, right? So now let's calculate this. This one, 1, 2, 3, 1, 2. So 15 times 10 divided by 2, 75. This one, 1, 2, then 1, 2, 3, 4. That's 20 times 10 divided by 2. This one is 100. Then this one, that's 5, 1, 2, 3, 4. 20 times 5 divided by 2, 50. Then this one, 1, 2, 3, 4. Then that's 20 times 5. That's 100. So if you add this together, that's 200, then 300. Right? Now let's see. This one, 1, 2, 3, 4. 4, that's 20 times 10, that's 100. This one, 1, 2, 3. Then 15 times 10, 75. Yeah, 325, right? This add together, that's 125. Then plus 200, 325 minus from 1, 2, 3, 4, 5, 6, 7, 8. This one, 8 times 5, that's 40. This one, 1, 2, 3, 4, 5, 6, 7. 7 times 5, 35. So that's 40 times 35, then minus 325. You still will get a 1075. There's two ways, okay? Then, now let's see this one. Actually, we already finished this section. Now let's go to the homework. Let's see if we have some problem is harder. We can try that one here. Okay, see this last homework, 11.2.8, this problem has a star here. That means this one's harder. Now let's see this problem. In this figure on the right, the angle EAB, this one's right angle. Okay, they give you this one, it's a right angle. And E and angle ABC, this one's also a right angle. Then AB equals 4, BC equals 6, and AE equals 8. And AC and BE intersect at D. What is the difference between the area of ADE and BDC? Okay, this one and this one. They ask you what is the difference between these two triangles. So first, you need to calculate what is the area of these two triangles. So first, anybody can calculate ADE? What is the area of this triangle? Then what is the area of BDC? Now let's see. Area of ADE equals area of ABE, this right triangle, minus area of ABD, right? Minus area of triangle ABD. Then now let's calculate area of BDC. This one equals area of ABC minus area of ABD, right? Then now we can write this one. ABE equals what? Area of ABE, that's 4 times 8 divided by 2, that's equals 16. Then minus area of ABD. Then area of ABC, that's equals 4 times 6 divided by 2, that's 12. Minus of this one, ABD. Then they ask you what is the difference of these two triangles, area of triangles. Now let's see who give me the answer. Okay, Grace, you are good try. Julia, correct. Sean, correct. Who else? See, I already almost write the answer for you. So then say you use area of ADE minus area of BDC. They ask you the difference, right? Then this one equals 16 minus area of ABD. This is the area of ADE, right? Then this one minus area of BDC, that's 12 minus ABD. Then you expand this, take the bracket away. You got this one 16 minus area of ABD, then minus 12, then plus area of ABD. Then the minus and plus cancel out. You got a 16 minus 12, you got a 4. So that means 4 is correct answer. Sophie also got it correct. Okay, very good. Then everybody, you already know the homework. That's all left exercise problem in the section 1 and section 2. Then at next time we'll learn the start from the section 3. That's circle. We'll finish this chapter next time. Thank you. Time is up. Bye. See you next time. Bye.
Bye, thank you.
Bye.
Thank you.